Hi everyone, my name is Akshat Diman. I'm a master's student at Northeastern University pursuing cloud computing and application management. For the past few weeks, me, Marshi, and Kanav have been working on Kubernetes Response Platform, which is an AI-powered incident response system on Amazon EKS that detects production failures, gathers context across metrics and logs, generates a structured root cause analysis using Claude, and it posts the diagnosis to Slack within seconds of an alert is firing. This project demonstrates an end-to-end cloud-native engineering, infrastructure as code, GitOps, observability, alerting, and an LLM integration that turns raw alert metadata into an actionable tried steps. So let's have a look at the Python microservices which are running on Amazon EKS. This is simulating an basic e-commerce backend. When they break, the Prometheus catches it through alert system, and Alertmanager routes the alert to a service that we built called incident service, which is this. So the once the incident service receives an alert, it gathers the context like matrices, logs, and Kubernetes health checks from the Kubernetes API, and matrices from Prometheus, and logs from Loki. Then it pushes it to Claude API, which we are using Claude Haiku, and then the Claude and then the Claude, what does Claude do is that it gathers all these matrices and logs and give an actionable feedback or a root cause analysis and post it up to Slack. So that's the whole idea about it. So that the 3 a.m. on-call engineer does not have to look around all these matrices and logs and run and deep dive into the analysis for logs, which might take up to 30 minutes. So instead of that, we are just providing a solution that the engineer receives an SMS on Slack or an email, which the engineer have a look over it and checks the remediation steps. So we have a sample email here or a sample uh, Slack message. So we get a root cause for this. So we injected some test scenarios here, and we are getting this consumer failed before injection. So this is the root cause, and the evidences are here. So a confidence level for this and the steps which a human could perform. So everything is taken care by Claude for this report analysis, and this Slack we have integrated using the webhook. So all this infrastructure has been provisioned using Terraform, and we are using Prometheus for matrices, logs for Loki for logs, and this is a dashboard for the on Grafana, which sees which have like all the logs and matrices and latencies over here. So right now, let's take a look at all the healthy state. Yeah, so this is Argo CD, which shows 5 applications running on it. Uh, this incident service, load generator, payment service, order service, and Nginx. This SQS publisher is for SQSQ, which is queuing service. And these are the alert rules which we have configured into our application, which I'll show you later. So uh, once the Argo CD analyzes any change, we are using Argo CD for GitOps perspective. So if we push anything from GitHub to from the bash or your local to your GitHub, the Argo CD detects the changes, and the port frequencies are for 3 minutes over here. And once the Argo CD detects the changes, it refreshes and syncs the application with the syncs the application running on the Kubernetes with the GitHub. So that's how we are managing the Argo CD and GitOps perspective. So now let's just now let's just try to inject a failure mode into our application so that we could analyze like if anything breaks into this the three of these services, then how our SPSQ is gonna like utilize the all these alerts and push it to incident service. So once the incident service receives the alert from the queue, it will like go and fetch matrices from Prometheus and logs from Loki and Kubernetes events from Kubernetes API. and it will package it and ship it to Claude API, where Slack will analyze it and push it to where the Claude will analyze it and push it to Slack. So this is our payment service deployment YAML, which has a variable named failure mode. So on purpose, we are going to inject a failure. Its value is used to be none, but now we are going to flip it to errors so that the which makes the service return of 500 seconds on 30% of the request like pushed by users. So I'm gonna flip this to errors, and now I'm going to push it to GitHub. Before that, just have a look at the verify if all the pods and everything is working fine. Yeah, everything is sync and healthy. All the monitoring pods are running, and all our services also up. So now I'm just gonna push it to GitHub. Mm. So now Argo City will come into the picture, and what it will do is that it will detect the change on GitHub. All right. Argo City, yes, it is up and running. I'm running it on localhost. So once it detects the change on GitHub, it will refresh the payment service and try to sync it with our cluster. So right now we are seeing the status as healthy and sync. So the poll frequency is for 3 minutes for Argo CD. So every 3 minutes it will detect the changes which have been made on the GitHub, and based on that it will just sync it with Kubernetes. So let's just not wait for it to do. I'm just gonna, for the sake of time and the sake of the length of the video, I'm going to refresh it right now. So as you can see, it was out of sync, and the pod is progressing right now, which will be same on cluster. See, and we'll restart the pod as well. Yeah, payment service restarted in 17 seconds. So if we go for this logs, we'll see the errors in failure mode right now. Yeah, as you can see, turning for 30% users, it is returning 500 error, 500 seconds of delay. So the same will be captured by Prometheus as metrics, and it should show that the order service high rate is firing and payment service high rate is also firing. So this alert must have, so right now it is in pending state. So let's just wait for it to go on a firing state. So once this alerts has been captured by Alertmanager, so the alert manager will, what it will do is it will push these alerts into the queue, which will be here. So we are using this queuing mechanism so that no alert in this entire pipeline goes missing. So what if, like the scenario is, what if the Kubernetes, this incident service is down? What if that a consumer is down? So what, like how this entire system is going to capture the logs for it or the alerts for it. So what we have did is we have implemented this in this SQS queuing mechanism, so that each and every alert goes into the queue, and later it will be like, so even if the consumer is down, the queue will hold the alert and then it will push it to the incident service, which is our consumer. So right now, SQS publisher and Still coming. So I'll pause the video until it gets to the firing state, and then we'll have a look. So now we can see all these alerts which are firing right now. So order service high rate is firing, and payment service high rate is also firing. And it is stating that they these many users like 500, yeah, this returning 500 for user 61 and the other users also. So this is an 500 internal server error, which has been captured by these matrices on Prometheus. And the alert has been fired, which is this. And the as I explained, the security mechanism, the incident service would have captured and posted to this uh, Claude. So around 2 minutes ago, received a Slack message stating that the payment service high error rate, which is also has given us the analysis for the root cause, that is payment services configured with failure mode errors. So as I mentioned, that this is the test scenario. So this is what we are getting in the root cause, and these are the evidence for it, and the confidence is high. So it is proposing a mediation that we should roll out restart a deployment, but we know that the failure mode, as we can see in the error, the failure mode has been set to errors. So for a normal human, that would understand that maybe this environment variable values has changed or it's not up to what it has to be. So as mentioned earlier, the order service is dependent on payment service. So it also is firing up and it is taking a payment service running 500 intervals of error. So due to which the order service is failing. Also, kubelet is running at capacity, too many kubelet pods. So everything we get using the Claude. So the entire point is that the 3 a.m. on-call engineer doesn't have to like have a look entirely on its cluster for the entire night, and also like it becomes uh, very convenient for an engineer to receive SMS or an email like this, through which he doesn't have to bank his head up on the cluster and go and check here and there about the infrastructure. So that's the entire point of making this project, and also making it an event driven architecture. So that's why we have implemented the SQS and SNS. This is still in the future scope so that we could receive an email, and parallel monitoring part to like have a look at our this stack. So also we are going to move it forward to uh, AWS managed Prometheus, and for logs we're going to use probably CloudWatch rather than using Loki. And that's just it. Yeah, thank you. Hi. Let's just take a look at our V2 architecture, which we designed so to implement the SQS queue. So here, what we are going to see is that what if the incident service is down, how the queue is going to store the alert, and once the incident service is back, then it should be able to send the message to Claude and then to ultimately to Slack. So what we are going to see here is the four bash windows. So one is running the incident service health check, logs. And this is my SKSQ publisher, which I forwarded on the port 80. And these are my timestamp for which are running on the CloudWatch metrics, where I'm seeing the matrices or the calls for the number of messages sent from our SQSQ to the Claude API, okay, or back to the incident service where it will gonna take to Claude. So for this, what we are gonna do is that we first of all need to delete the incident service so that I'm removing the this consumer from the picture. So once it is removed, the SPS should be able to store an alert. So right now I will be firing an sample alert. Okay. from the console itself. Okay, so mm, yeah. So I'm first of all, what I'm going to do is I'm going to force delete this pod. Yeah, done. And now I'm going to push this alert here. So I'm going to run back the logs for it. See, it in the logs it says that SQS poller stated that the queue starting of the queue Amazon this incident alerts. Yeah, and probably write down the part we are gonna see the alert with the timestamp here. So right now it tells the time zone is in UTC. So that is what we are gonna see in the queue. Also on the AWS, we must see per time monitoring phase. So this is the age of our oldest message, which is around 52 milliseconds, I believe. And no messages has been delayed because that pod restarted because of the deployment, which has mentioned its replicas. And well, that's why our pod just restarted within few seconds and the queue just stayed, the message just stayed in the queue for this much millisecond. And that's the approximate number of messages which are not visible and the other matrices. So the ultimate point is that this must receive the SMS from these Claude. So right now it's 11:09, and this message has been received at 11:08 a.m., stating that this is a test alert, which we just fired from the console. Thank you.